Hello again, dear grade 11 students, and as I promised you, this video is about another training exercise in solving systems of quadratic inequalities. And here we go with the second example. We have x greater or equal to minus 1 over x minus 1 and 4x squared plus 5 over x squared minus 4x plus 4 is less than or equal to 1. So as you notice, every time I'm coloring the first inequality with blue and the second with with red, so we can differentiate between them. Now, according to the first inequality, all what we have to do is to take all of this to the other side in order to make it 0. So we have to make x minus 1 over x minus 1 greater or equal to 0 by making the same denominator. So we put x over 1, we make the same denominator, we multiply x by x minus 1, then we'll get x squared minus x, and minus into minus is plus 1 over x minus 1 is greater or equal to 0. Pay attention, you don't have to make cross multiplication. It's wrong to put 0 over 1 and to make cross multiplication in inequalities. We have to study the sign of the numerator and the denominator and then to get the sign or the solution for all of this rational form. Now the roots for the numerator, notice that if we use the calculator, we are going to get no real roots. As I mentioned in the previous video, we can know if the equation has real roots or not according to the obtained values. So here we go. For example, a here is 1. Let's see. B is minus 1 and C is 1. Notice what you are going to get. Notice the I here. That I means complex, so there are no real roots for this equation, x squared minus x plus 1. Okay, so whenever you get I on the calculator, then this has no real roots, which means that delta is negative. Okay, so this is a clue how to know that delta is negative or delta is positive. If the roots are obtained normally as real numbers, then we conclude that delta is positive. And if we press another equal and we get the same root, then we can consider it a double root. So this is how to use the calculator to know what are we going to do. Now here, since we get I, then there are no real roots for the numerator. Delta is negative, and thus this will have the same sign of A. As you know, whenever delta is negative, we take the same sign of A, so it is always positive because A is positive, so i.e. it is positive. Now, according to the denominator, of course, x minus 1 should not be 0, then x should not be 1. So 1 is the root of the denominator, and we have to put dashes on it because it must not occur. X minus 1 should never be 0, thus x should never be 1. Now we put the first one, the numerator, on the table, and here the root, the only root is 1. It's for the denominator. This has no roots. And we put pluses for it because it's always positive, as we mentioned here. X minus 1, because it's linear, then before the root we put the opposite sign of x, and after the root, its root I mean, we put the same sign of x. Thus we have to put minus and plus. Now plus times minus is minus, plus times plus is plus, and here is 1, I mean this inequality or this expression. So S1, we need greater or equal to 0. So we need the positive part. Okay, we need the positive part, which is this part from 1 to plus infinity. Okay, but we have or equal, but we append it at 1. Why? Because 1 is a rejected value. We don't, as an excluded value, we don't have to get x equals 1. That's why we append the interval at 1 even though we have or equal. Now, according to the second inequality, for the numerator and the denominator, we cannot start unless we take 1 to the other side, as you see here. So we have to put 0 here. So taking 1 to the other side, we get 4x, and making the same denominator as well, we put it over 1 again, as we do every time. We multiply it by x squared minus 4x plus 4. By this denominator, we are going to get 4x squared plus 5 minus x squared plus 4x and minus 4. we introduce the minus sign. Over this, it stays the same. Then we get 3x squared above, plus 4x, and plus 5 minus 4 is 1. Now using the calculator, let's use it again. So using the calculator, here is A is 3, B is 4, and C is 1. I mean the numerator. Notice the first root is minus 1 over 3 as you see here, and the second root, we press another equal, it is minus 1. So whenever we get 3 roots, that means that delta is surely positive, and we are going to use the idea of SOS. Same, opposite, same, based on the sign of A. Now, for the denominator, let's see the root of the denominator. A is 1, B is minus 4, and C is 4. Notice what we are going to get. X equals to another equal, so it's just 2. That's what gives us a clue that this is a double root. So again, it is 2. So x is only 2, and that means that we have a double root. Now we arrange the roots on the table as you see here in the increasing order. First we put minus 1, then minus 1 over 3, then 2. Here is the numerator. Its roots are minus 1 and minus 1 over 3. As we tell you here, same, opposite, same. So same sign of A, then between the roots, the opposite sign, which is minus, and outside the roots, between minus 1 over 3 and plus infinity, it is the same again of A, the same sign of A. Now, according to the double root, means that delta is 0. Delta equals to 0. Again, we take this sign of A as if delta is negative. So when delta equals 0 and delta is negative, we take this sign of A. But the difference is that when delta is negative, no roots, as you see here, no roots. When delta is 0, there is a double root, as you see here, which is 2, and we put dashes because it is for the denominator. So all of the signs are pluses because we have to take this sign of A and it is plus. Now we have to search for less than or equal to 0, which means I'm searching for the negative part, which is here, and only here. So the negative part, we need to take it is here. Plus times a plus is plus, minus times a plus is minus, and here are pluses. So the only negative part is found between minus 1 and minus 1 over 3. We close it at minus 1, we close it at minus 1 over 3 because we have or equal, and we don't have dashes on these numbers. These are not excluded numbers. Let's see now finally the solution, the final solution of the system. So we take the values appearing in the solutions 1 and 2. Here is 1, here is minus 1 and minus 1 over 3. We arrange them in the increasing order as you see on the number line. Now the first solution in blue goes from 1 dashed because it's opened at 1 till plus infinity. And for solution 2, the red one, it's among minus 1. It's closed at minus 1 and closed at minus 1 over 3. That's why I'm going to make it, to correct it, I'm going to make it discrete here and here. Is there any intersection between them? No, there is no intersection. So the solution is empty, set. It is phi. That means I cannot find a number x, a real number x, or a set of real numbers that satisfies this inequality and this inequality at the same time. That's what we mean by the solution is empty. No intersection on the number line. That means that no real numbers can satisfy these two inequalities together at the same time.